Based on the open source Quake 3 Arena 1.32 Bravo version, the GPL version of the Quake 3 source, we add compilable feature code segments and modification hooks into the Quake 3 game engine. These include things such as ladders, locational damage, weapon features, and other aspects of the game that do not exist in the Quake 3 Arena base. These often comprise elements that are used in game modifications. So by using compiler flags, you can select which features you want compiled into your game. We also provide interfaces into perception and control of the player within the Quake 3 modification environment. We also provide a logging service to put player data into a database or a flat file, and then tools such as visualization and analysis tools can be used on top of this information to provide player traces and analysis of player performance. Perception support tools include elements such as the static spatial perception service, which will take non-dynamic information, static information about the environment, and provide it to an external agent. We also provide Mission Profiler, which tells an agent what goals need to be accomplished in the current scenario they're loading. Level design tools, such as Radiant, can be extended to provide additional elements that are not part of the original Quake 3 Arena, but are part of a modified game, so that those design elements can be incorporated into the game. We also include hooks that allow a level designer to be able to provide information such as semantic tags to objects within the environment, which could be used for perception support. Also, the external agents can be created that can play in the modified Quake 3 game. These agents can also use advanced AI techniques. For a level design tool, we use the open source GTK Radiant. As you see, the tool starts open. We can select one of our scenario environments, bring it up, and due to definition files attached to our modification, in this case the Urban Combat Testbed, we can make modifications to levels and include objects that are relevant to the particular modification. Urban Combat Testbed is based on realistic scenarios, so here you see an environment we call UCT apartments, which is a set of apartments in kind of an open courtyard area. And now we actually load up what we call, which is UCT apartments, we used to call Reykjavik, and you can see a human player moving around the environment with our own custom heads-up display. And as we move around, you're going to kind of get a feel for the realism involved in this particular environment for this particular mod made with the Q3 mod base. So when human players play the game, their movements can be logged and their interactions with the game tracked, and a player model can be generated from their interaction with features of the environment. We've actually mapped these environments down to convex regions, and so we can actually observe strategy by human players in the environment, and then if we want to compare it to agents, we can compare agent strategy versus human strategy, and here we enter a bot that we played against. Now we look at agent players. In this case, this is one we have under development where an agent is loaded up, and now this is just an agent interacting in the environment. And this agent is feeling its way along a wall, and it's doing some mapping actually, so it's keeping track of all the coordinates that it actually can move around in, and is trying to build an internal map of the environment. And eventually we will train the agents to go against adversaries and incorporate different strategies into these environments, often using semantic information attached to models. And we've been using research psych and psych constants to ground objects models in the environment. So our interface tools that help us create agents. In this case, it's using some older versions of the tools that we used to be based on a different mod. And so we bring up the Urban Combat Testbed, bring up the right map, and you're going to see in this case, this is the effector interface where we have all of those controls to control an agent, a launcher under there, and we'll also bring up the percept interface. So once we set up the Urban Combat Testbed, we can now actually use this shared memory interface in this controller to interact in the environment. And this can be used in conjunction with an agent if you want to override sections or actions of an agent. It can be used to test that interface, and also provides a code base to provide an example of how you would create the shared memory controls for an agent. And you can see in this case it's being human controlled through this interface and interacting with the environment. And then we're going to bring up the percept interface, in which case we bring up all of the dynamic percepts. We also have the static spatial perception service, or we call SIPS, and it will currently provides a topological view, and pretty soon we'll provide a detailed view of the static geometry. And here you see some of the percepts we get from the agent interacting in the environment. In this case, it's being interacted through the effector interface, and all this is being transferred in shared memory, so it's extremely fast, and so there's almost no latency, so you don't have to worry about socket communications. You have a direct coupling into the Quake 3 mod engine. So one of the things we're taking great care of, and as we develop the Q3 mod base and our modifications, is to make sure that we have good documentation for all the code. We use Doxygen to produce these files. We also document every little step of the way and every modification we take in the engine so that it can be reproduced and it can be used as a teaching tool.